when we have two lines in space, we can classify these two lines three different categories. First, of course, the two lines are parallel, they do not meet, and they don't form angle between them. The angle between them, say theta, is 0 degrees. The second situation would be when the two lines do meet, and there's a point of intersection right here, the angle formed between them. The third situation is what we call a skew line. These two lines, they do not meet, and yet they are not parallel. So think of something like this. First we have the first line, and the second line would not meet the first line. It goes under or goes above the line. Although they do not meet, they still form an angle. We can do that. We assume that we can translate the red line so that it meets the blue line. The first line with the second line, and in the end you get some situation like this. Although they actually do not meet, and there's an angle formed between them. You can find this angle too if you want to. Now let's look at examples about classifying two lines and also finding angles between the two lines. And look at this problem here. For this first line, I'm going to call it L1. The second line, I'm going to call this L2. And L1 has direction vector, and I'm going to call this direction vector as U. You can see that the direction vector of U is formed by the coefficient of t, so 2, -1, and 1. And similarly, we can then also write down direction vector of line 2, L2. Let's call it V, and that will be 3, -1, and 2. And this, why is -1? Because here 3 clearly, and then the last component 2. This should be something like y minus a value divided by a value, but now you see it's 3 minus y. Clearly, know the whole thing is divided by -1, so we know that this component is -1. These two vectors here show that both lines are not parallel, but the thing is whether they intersect or not. So what we're going to do is we're going to substitute equations of line 1 into line 2. This is a very standard approach if we want to find intersection point of two lines. We substitute the lines with the parametric form into the lines with Cartesian form or Cartesian equations. Anyway, here we substitute this, and we will get 1 plus 2t plus 2 over 3 equivalent to 3 minus 2 minus t, and that be equal to 3 plus t minus 1 divided by 2. And what we need to do now is to find the value of t, or whether they are the same or not. And we take any two pair, any two to form one pair. So I'm going to take this plus 2, and if I solve this, I should be able to show that t is 3 minus 2 minus t, and solving this I will get t equals 0, and then I take another 2 to form one pair, one of these two, and solving this I will get also t equals 0. It means the two lines intersect at the point when t equals to 0. So when t equals to 0, you can find the xy the old coordinates by using this here. So I have 1, y equals to 2, and z equals to 3. So that will be the point where these two lines intersect, 1, 2, and 3. And to determine the measure of the angle between them, we can suppose these two lines at the meet, that's the point 1, 2, 3, and this is the angle we're talking about. How do we do this? Now, very simple. For the first line, we know this direction vector as u. We know the second line is direction vector is v, and using what we know about the angle between two vectors, or the definition of the dot product, that is this, u dot v is equal to the magnitude of u, magnitude of v cosine theta. So you can find theta as arc cosine u dot v, the magnitude of u dot v, divided by u, magnitude of u, and magnitude of v. And if you calculate this, the answer, or would be something about 10.9 degrees. Another thing that we could calculate would be the shortest distance between skew lines, and we'll look at that in the next video.